In 7.3, we're exploring compound events, and we're still looking at the probability part of it. But examples 1 and 2 kind of pave the way for that a little bit more than 7.2. And what I mean by that is in 7.2, on all of our problems, they told us the total number of possible outcomes. That information was given to us. In 7.3, we actually have to find the total number of outcomes before we can find probability. All right, so before we can calculate favorable out of total, we have to find how many total outcomes there are. And there's 2 ways that I can find that. All right, so what do you think compound means? What do you think compound means?
Together.
Two or more. Okay, so it's not single, it's not a single event. And that's also how 7.3 differs from 7.1 and 2. In 7.1 and 2, it said probability of an odd number, or probability of landing on a 3, or probability of flipping a heads. It was one event. Well, in this section, it's going to be rolling a 3 and flipping a heads. Okay, so there's a number cube and a coin, and both events have to happen in order for it to be a favorable event. All right, so that's what we mean by compound events. All right, so one of the terms you need to know, and I'm going to give you another definition here in a minute, is sample space. All right, that's another word for sample space is tree diagram. Maybe you've heard of them, tree diagrams, but we're going to do one of those in example 1. And this shows us the set of all possible outcomes, and here it goes, of 1 or more events. Okay, the more part is what we're looking at today, because we're going to look at the set of all possible outcomes of 2 events. All right, so that's a sample space. Okay, so let's look at example 1 now. In example 1, it gives me some sandwich options and 2 types of bread options and 4 types of sandwich options, all right, that I've displayed here in a table for you. So we're going to take the information from the table and we're going to establish the answer to this question. How many different sandwiches are possible with the options that were given? Okay, so it technically does not matter which category you start with, whether you start with bread or you start with a type of sandwich. What I would encourage you to do is this, to start with the category that has the fewest options. To me, it's easier to start here and expand it than it is to start with all of the options and then make it smaller, but technically either one is okay. All right, so which category has the fewest options? Bread. Okay, so bread gets its own column because it is a category. And what are my 2 options of bread? Wheat and sourdough, which we're going to abbreviate sourdough SD. Okay, all right, so that's my bread. And then what types of sandwiches can I choose? Once I choose my bread, what types of sandwiches can I choose? Ham, turkey, steak, and chicken. Okay, so that's if I pick wheat. Well, what if I pick sourdough? What types of options do I have? The same 4 options. So once I pick my bread, I pick one of my 4 types. And then once I pick my sourdough, I have one of 4 types again. Are you following me? I know it's a little bit of writing and a lot of you guys are busy writing. Okay, any questions on that? All right, so we're creating a tree diagram. It's not necessarily difficult. It's just, it takes a little bit of writing. All right, and once I have my types listed and matched up, now I bring them across and I'm just writing it out. So if it's wheat ham, then I come over here to my outcome and I write wheat ham. That's one option. And then wheat turkey, so I come over here and guess what I'm going to write? Wheat turkey. Okay, so go ahead and write down all of your options. Right now on your homework assignment, it does ask you to make a tree diagram. okay, in one of the directions, so that's where this would come into play, all right, to set up your tree diagram. All right, so go ahead and finish writing down your tree diagram and all of your possible outcomes.
Are you supposed to do like the?
So let's finish our outcomes. Okay, wheat and steak, wheat and chicken, sourdough ham, sourdough turkey, steak, and chicken. Okay, so how many total outcomes are there?
8.
Yes, there are 8 total outcomes. All right, and here's how, and I actually did not do this in 6th hour, but I think it could be helpful for you to kind of tie it into probability. All right, remember with probability, we need to divide favorable divided by possible, okay? So if I were to explore probabilities here in this example, all of my denominators would be 8 because that's how many choices I have here. All right, so let me throw out a probability scenario to you. What is the probability that I would choose a wheat turkey sandwich?
1.
How many options are wheat and turkey? 1. So I would say 1/8. Okay? All right, now you got to kind of know your meats here. Okay? So that's 1/8. What is the probability that I would choose sourdough and a white meat? So how many of those are white meats?
1, 2,
Turkey is a white meat. Think about the color of it. Okay, steak we know is a red meat, right? Ham is a red meat. Chicken is white meat. So how many options are?
2 8. 1 4.
Okay, so let's go back here. Okay, sourdough. That we picked sourdough and a white meat is sourdough turkey and sourdough chicken. So I heard it would be 2/8, but then I would reduce it to 1/4, which is 25% if I were to make it a percentage. All right, are you seeing the tie-in? In your book, in example 1, it does not take it over into probability, okay? So really what we want to get out of this example is finding the total number of possibilities with a tree diagram. But how it connects into probability is extremely important, which is why I showed you that part, okay? So hopefully you're kind of seeing that connection there. All right, so on example 2 now, I'm going to show you a different way to calculate the total possible outcomes. So again, tree diagram, really what it does 2 things. It shows us kind of the breakdown, which can be helpful, that's for sure. It shows us the breakdown, which can be helpful. But really what it's getting me is the total number of outcomes so I can calculate probability. Remember, I can't calculate probability without a total, okay? So in 7.2, it gave me the total, and in 7.1, but in 7.3, it doesn't. I have to calculate it. There's actually an easier way, especially if I have multiple categories and I want to avoid a tree diagram that is like bigger than my sheet of paper, okay? There's another way that I can calculate the total number of outcomes, and that is the fundamental counting principle. It says that you can multiply the possible outcomes from each category together to find the total number of possible outcomes. So now I want you to draw the table, okay, that you see here on this page, and then we're going to look at the fundamental counting principle and how we can use it. So if all right, well, the first part to this is we need to understand there are 6 sides to a number cube, okay? 1, 2, 3, 4, 5, and 6. And that's what we see here. These are my outcomes if I were to roll a number cube. All right, then if I were to flip a coin, I can either get heads or tails. So the blanks that I see in the chart show basically if I were to roll a 1, I could either flip a heads or flip a tails, okay? So it's either 1 heads or 1 tails. So what do you think 2 is going to be? 2 heads and 2 tails. And then 3, 4, 5, and 6 are the same thing. All right, so we're just going to kind of finish filling in the chart. Okay, 6 heads and 6 tails. All right, so before before I can calculate any probabilities, I need to know the total number of options. Well, let's pretend for a minute, and on the next slide, this is the case, but let's pretend for a minute that it's not set up in a table. I need to know how many possible outcomes there are on a number cube. And how many is it? How many outcomes? There are 6 outcomes on a number cube. How many are there on a coin? 2. So the fundamental counting principle says I can take the total from each category and multiply it together to get 12. Okay? I can get 12 potential outcomes. So that's important because that's my total for any probability that I'm trying to find. All right? You with me? Right, so we're going to come back to this example in just a minute to calculate probability. But before we do that, I want to explore the fundamental counting principle a little bit more with you guys to hopefully help you understand it. Turn in your books to page 301. Page 301 in your books. As much as I tried, I could not get this picture of the closet onto my PowerPoint. So we're just going to look at the picture of the closet underneath example 3 on page 301. I actually did try to start drawing it, and I was like, yeah, forget it. All we need to do is find the totals for each category from the closet. So how many pairs of pants do you see in the closet?
2.
No, pairs of pants up on the shelf.
4.
There are 4 pairs of pants on the shelf. How many shirts do you see hanging?
7.
All right, how many is it?
7.
Okay, so we see 4 pairs of pants. We see 7 shirts. You need to be writing this down. We see 7 shirts. And how many pairs of shoes?
3. See, I thought you were going to say
All right, 3 shoes. Okay, so fundamental counting principle says in order to figure out my total number of possibilities, which I need to know to calculate any probability, I can multiply the totals from each category by each other. So what's 4 times 7 times 3?
84.
84 outfits. 84 outfits. Okay? 84 different outfits. All right, now I want you to calculate the second one. Go ahead and calculate the second one. All right, so in the second one, it gives me the totals. So all you have to do is multiply 4 times 5 times 5. The total number of possibilities from each category. And what's 4 times 5 times 5? 100 outfits. Okay, so there are 100 potential outfits. All right, and really to be able to see the true breakdown, I would want to have a tree diagram, okay? And that's what example 5 kind of ties into a little more, is those tree diagrams show us all of the different possibilities. Do you think a tree diagram with 100 possibilities is going to be a pretty big chart? Okay, so you're not going to see them that big, but calculating the total number of outcomes is really, really important. All right, so now we're going to look at one more example, and this is the one that we're going to need to come back to on Monday because we're running out of time, but I at least want to start you on it. All right, going back to example 2, going back to the chart. All right, using that chart, what is the probability of rolling a number greater than 4 and flipping tails? All right, well, one thing that's important, so look back in your notes, is in order to calculate probability, I must have what value in my denominator? The total. So that's what I did in example 2, was I recognized that there are 6 options on a cube and 2 options on a coin, so my total number of options are 12. Now I have to go back and ask myself, how many numbers are greater than 4 on the number cube? How many? 2 numbers, a 5 and a 6. So now, at this point, there are 4 possibilities. 5 heads and a 5 tails, a 6 heads and a 6 tails. But then, there are only how many possibilities? There would be a 5 or a 6 and tails. How many does that narrow it down to? Only 2. 5 heads and 6 heads. Sorry, I just messed it up. 5 tails and 6 tails are the only 2 options that meet both criteria. Does that make sense? It has to be greater than 4 and tails. Well, 5 tails and 6 tails are the only 2 options, so it's going to be 2 over 12, which is 1/6,
Which is 0.16 repeating.
which is as a percent.
16.6%.
Yep, 16.6 repeating percent.
Is it
Okay.
because it's 5 and 6?
Correct. It has to be greater than 4 and tails. So it could be 5 tails or 6 tails. Why couldn't it be 3 tails?
Because that's more.
Because it doesn't meet both criteria. It's not greater than 4. Why couldn't it be 5 heads? Because it had to be tails. So it has to be both. Okay? All right, so now let's answer the second question. What is the probability of rolling at most 4 and flipping heads? So we need to understand what at most means. It's been a while. What does at most mean? 4 or less. Can't be more, so it's at most 4. So it could be a 1, 2, 3, or a 4. So at this point, I have 8 possibilities, but now it also has to be heads. So it could be, I want you to write down which outcomes could be favorable and meet both of those criteria. Go ahead and write them down. I want you to list them. All right, and this is just practice. It's not necessarily part of solving. Okay? So what's my first favorable outcome? 1 heads. Is 1 at most 4 and also heads? Yep. What's another one? Tell me. 2 heads. What's another one? 3 heads. What's another one? 4 heads. Is 5 heads one?
No.
No, because it doesn't meet the first criteria. So how many favorable outcomes are there? 4 out of how many? 12, which is 1/3, which is 33.3 repeating percent. Okay? Any questions on calculating probability? We will continue exploring the calculating probability part on Monday. For now, this is everything you need to know, and I'm adding it into the YouTube video so you can fast forward to the end, but I'm also updating the portal that I am delaying 7.3 homework until Monday night. It is not your homework that is due tomorrow, okay? It's due on Tuesday, and if you understand that, that's everything you need to know for 7.3.